Class 8 Maths, Chapter Rational Numbers, Lecture 1, Module 1. Rational Numbers. Maths is the study of numbers, formula, geometric shapes. Numbers. Natural number. Natural numbers are those numbers that are the counting numbers, like 1, 2, 3, 4, 5, in this way. These numbers came to you naturally. Whole numbers. An ancient Indian astronomer named Arjyavat discovered zero. So, whole numbers are those numbers that starting from zero. So, 0, 1, 2, 3, 4, 5, etc. The collection of number which includes all the natural number and the zero are called whole number. Write the biggest whole number. Whole number starts from 0 and goes to infinity. So that means there is no limit of the numbers. It is not possible to determine biggest whole number. Three plus 4 gives us 7. It is a natural number. It is also a whole number. 2 minus 3 gives us minus 1. It is a natural number. No. It is a whole number. No. So there came the concept of integers, which include whole numbers as well as the negative numbers. Commutativity. Two rational numbers can be added in any order. For addition, let us take an example. 0 plus 7 gives us 7, and 7 plus 0 also gives us 7. So that is 0 plus 7 is equal to 7 plus 0. So for any two whole numbers a and b, we can write that a plus b equal to b plus a. So what do you observe? Addition is commutative. Now the operation subtraction. Let us take an example. 7 minus 0 equal to 7, and 0 minus 7 equal to minus 7. So what do you observe? That 7 minus 0 is not equal to 0 minus 7. So subtraction is not commutative. Two rational numbers can be multiplied in any order. Operation multiplication. Let's take an example. 0 multiplied by 7 gives you 0, and 7 multiplied by 0 gives you 0. That is 0 multiplied by 7 is equal to 7 multiplied by 0. So for any two whole numbers a and b, a multiplied by b gives us b multiplied by a. So what do you observe? Multiplication is commutative. Division. Let's take an example. 7 divided by 0 is equal to not defined, and 0 divided by 7 is equal to 0. So what do you observe? That 7 divided by 0 is not equal to 0 divided by 7. So division is not commutative. Module 2. Associativity. Three rational numbers can be grouped in any order. Operation addition. Let's take an example. 7 plus within bracket 2 plus 5 is equal to 14, and within bracket 7 plus 2 plus 5 is equal to 14. So that is 7 plus within bracket 2 plus 5 equal to within bracket 7 plus 2 plus 5. So for any three whole numbers a, b and c, a plus within bracket b plus c is equal to within bracket a plus b plus c. What do you observe? That addition is associative. Subtraction. Let's take an example. 7 minus within bracket 2 minus 5 equal to 10, and within bracket 7 minus 2 minus 5 is equal to 0. What do you observe? That 7 minus within bracket 2 minus 5 is not equal to within bracket 7 minus 2 minus 5. So, subtraction is not associative. So, for now, multiplication, three rational numbers can be grouped in any order. Let's take an example. 7 multiplied by within bracket 2 multiplied by 5 equal to 70, and within bracket 7 multiplied by 2 into 5 is equal to 70. That is 7 multiplied by 2 multiplied by 5 within bracket is equal to within bracket 7 multiplied by 2 into 5. That is for any two whole numbers a, b and c, a multiplied by within bracket b into c is equal to within bracket a into b into c. So what do you observe? Multiplication is associative. Division. Let's take an example. 7 divided by within bracket 2 divided by 5 gives us 17.5, and within bracket 7 divided by 2 divided by 5 gives us 0.7. What do you observe? That 7 divided by within bracket 2 divided by 5 is not equal to 7 divided by 2 within bracket divided by 5. So hence division is not associative. Additive inverse. Write the additive inverse of each of the following. 2 by 8, So additive inverse means multiplying with negative 1. So negative of integers. So that is equal to 2 by 8 multiplied by minus 1 is equal to minus 2 by 8. So additive inverse means you just need to change the sign of the number. Minus 5 by 9. So minus 5 by 9 into minus 1 equal to 5 by 9. Minus 6 by minus 5. So since both have same sign, so we can write it as 6 by 5. So 6 by 5 into minus 1 is equal to minus 6 by 5. Multiplicative inverse. Write the multiplicative inverse of each of the following. Minus 13. Multiplicative inverse means the reciprocal of the integers. So minus 13, the multiplicative inverse of minus 13 is equal to 1 by minus 13. Or you can write it as minus 1 by 13. The multiplicative inverse of minus 13 by 19 is equal to 19 by minus 13 or minus 19 by 13. Module 3. Exercise. Find using distributivity. So now 7 by 5 within bracket multiplied by minus 3 by 12 plus 7 by 5 into 5 by 12. So now we need to find the common factors. So here common factor is 7 by 5. Now we need to find the uncommon factors. So uncommon factors are minus 3 by 12 and 5 by 12. So now we will add these uncommon factors together. Now in this case, since the denominator is same, so we will just add the numerator. That is minus 3 plus 5, that is equal to 2 by 12. Now if we cut it, we will get 1 by 6. So here comes 7 by 30. Now using appropriate properties, find 2 by 5 into minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 by 14 into 2 by 5. So the steps are shown over here. Please follow the steps. So since 3 can be easily cut with 6, so we will get 2 in the denominator in that case. So now it becomes 1 by 4. So now here we have used the commutative property. So we know that we can change the position of the number. So that's why we are bringing all the positive number first and the negative one at the end. Now in this case, we need to find out the common factors. So 2 by 5 is common over here. And we need to find the uncommon factors. So now this we have applied using distributive property. So since here numerator in denominator it is different. So we need to do here we can do the multiplication or either you can do the LCM of it. So this is the final answer, minus 11 by 28. Module 4. Using appropriate properties, find minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. So we can see that 3 by 5 is common in this case. So we will apply commutative property over here. Now we are using the distributive property to find the common factors, and we also need to find the uncommon factors. Now let us cut the numbers. So the final answer we got is 2. Name the property under multiplication used in each of the following. So now let's check. Is this in the form of a into 1 is equal to 1 into a equal to a? Yes, it is. So when we multiply rational number with 1, we get that rational number as the product. So 1 is called the multiplicative identity. Now lecture 2, module 5. Write 5 rational numbers which are smaller than 2. So 1 by 3, 1 by 4, 1 by 2, minus 1 by 2, minus 1 by 5, and so on. So there can be any other number also you can think. Find 10 rational numbers between minus 2 by 5 and 1 by 2. So first, in this case, what we need to do, we have to convert this minus 2 by 5 and minus 1 by 2 having same denominators such that the difference between the numerators is more than 10. Now in this case, the difference between the numerators is not more than 10. Because if you check, it is coming around 9. The difference is 9. So that's why we are again multiplying both the numerator and denominator by 2 to get a more range. So now the 10 rational numbers between minus 2 by 5 and 1 by 2 are, you can write any numbers in between these rational numbers. Find 5 rational numbers between 1 by 4 and 1 by 2. Converting 1 by 4 and 1 by 2 having same denominators such that difference between the numerators is more than 5. But the difference between the numerators is not more than 5. So now converting 1 by 4 and 2 by 4 having same denominator such that difference between the numerators is more than 5. Hence, we can take any number, but both numerator and denominator we have to multiply with the same number. So here we have considered 8. It's a bigger number. So we will get 8 by 32. In this case, we will get 16 by 32. So the 5 rational numbers between 1 by 4 and 1 by 2 are all these numbers. So any number you can consider between 8 by 32 and 16 by 32. Now module 6. Exercise. Verify that minus is equal to x for x equal to minus 13 by 17. So we basically what we need to do, we need to prove that minus x equal to x. So what we need to do, we need to multiply minus 1 on both the side. So now this becomes minus x, and minus that becomes plus. So now we have to find the minus of minus x. So again we need to multiply minus 1 on both the side. So now it becomes minus of minus x, and minus plus becomes minus. So we got minus 13 by 7. So minus 13 by 7 is the value of x that we already know. So from equation 1 and 2, we can conclude that minus of minus x equal to x. Hence proved. So for any proof type of verification type of problem, you have to finally write that hence proof after the verification is done. Find 5 rational numbers between 2 by 3 and 4 by 5. Again, converting 2 by 3 and 4 by 5 having same denominators such that difference between the numerators is more than 5. So here we have considered a bigger number. We are multiplying with 20. So anyways, we will get a big number. And in both the numbers, the denominator we have considered at 60. So now what are the next number between 40 to 48? Those are 41, 42, 43, 44, 45. So now any 5 rational numbers are these. So instead of multiplying 20 by 20 and 12 by 12, you can take any other, like you can take 30 also, or any other number, but you have to make sure that the denominator should be same with both the numbers. Find 5 rational numbers between minus 3 by 2 and 5 by 3. So converting 2 by 3 and converting minus 3 by 2 and 5 by 3 with same denominators, we have now we got same denominators. Now we need to find the next number between minus 10 to between minus 9 to 10. So those are minus 8, minus 7, minus 6, or you can consider 1, 2, 3, 4. So 5 rational numbers are these. Now find 5 rational numbers between 3 by 5 and 3 by 4. Converting 3 by 5 and 3 by 4 such that they have common denominators and their numerators have difference of more than 10 or more than 5. In this case, it will be more than 5. Now we got the same denominators. So now we need to find the numbers between 60 to 75. So these are the numbers. So the 10 rational numbers are these. Module 7. Find the multiplicative inverse of the following. So multiplicative inverse means we know that the reciprocal. So now what is the reciprocal of 2 by 5? That is 5 by 2. So reciprocal of minus 1 is equal to minus 1 by 1. That is same as minus 1. Verify that minus of minus x equal to x for x equal to 11 by 15. This we have done earlier also with another number. So I am showing you the steps how to do it again. So what we got is 11 by 15. So that is the value of x only. So now from equation 1 and 2 we got that minus of minus x equal to x. Hence proved. Module 8. Find the multiplicative inverse of the following. So let's take a look at the table. So we have to basically in multiplicative inverse we have to bring the numerator to the denominator and denominator to the numerator. So in this case first we have to simplify it. Now we need to do the reciprocal. Name the property under multiplication used in each of the following. So this is this in the form of a into b equal to b into a? Let's check. So it should be like minus 2 by 7 should be considered as b over here. So a into b is equal to b into a. So yes, this is in this form. So we call this property as commutative property. Now we need to find the reciprocal of minus 19 by 29. That is 29 by minus 19. So whenever a number multiplied by its reciprocal, then which property is used? That is called the multiplicative inverse. Multiply 6 by 13 by the reciprocal of minus 7 by 16. So first we need to find the reciprocal of minus 7 by 16. That is equal to 16 minus 16 by 7. So here comes minus 96 by 91. Lecture 3, Module 9. Tell what property allows you to compute 1 by 3 into within bracket 6 into 4 by 3 as within bracket 1 by 3 into 6 into 4 by 3. So let's check if this is in the form of a into within bracket b into c is equal to within bracket a into b into c. So yes, it is in this form. So what is this property called? This is called associative property or associativity. So here we have used the associativity property. Is 8 by 9 the multiplicative inverse of minus 1, 1 by 8? Why or why not? So the product of a rational numbers and its multiplicative inverse is equal to 1. So let's check. So we got minus 1, which is not equal to 1. Hence, 8 by 9 is not the multiplicative inverse of minus 1, 1 by 8 because the product is not 1. Is 0.3 the multiplicative inverse of 3, 1 by 3? Why or why not? Let's check. So we know that the product of a rational number and its multiplicative inverse is equal to 1. So we got the product is 1. So 0.3 is the multiplicative inverse of 3, 1 by 3 as the product is 1. Module 10. Write the rational number that doesn't have a reciprocal. That is the 0. Write the rational numbers that are equal to their reciprocals. That is 1 and minus 1. Write the rational number that is equal to its negative. That is 0. Now fill in the blanks. 0 has dash reciprocal. That is 0 has no reciprocal. Because 0 reciprocal means 1 by 0. So that is also 0. The numbers dash and dash are their own reciprocals. So 1 and minus 1. So 1, the reciprocal of 1 is 1 by 1, that is equal to 1. And reciprocal of minus 1 is minus 1 by 1, that is equal to minus 1. The reciprocal of minus 5 is minus 1 by 5. The reciprocal of 1 by x, where x not equal to 0, is x. We just need to swap the denominator and numerator position. The product of two rational numbers is always a rational number. The reciprocal of a positive rational number is positive. Module 11. Simplify 8 by minus 15 plus 4 by minus 3. So let's take step by step approach. So here denominators of both the rational numbers are not positive. So we are going to multiply and divide it by minus 1. So that we can make the numerator as negative and all the denominator as positive. Now denominators of both the rational numbers are not equal. So let's make them equal by taking the LCM of it. So LCM of 15 and 3 is 15 only. I hope this is self-explanatory. So now the denominators are equal. Now we have to add the numerators. So we got the final answer as minus 28 by 15. Add 5 by 2 and 3 by 8. So here the denominators of the rational numbers are positive, but the denominators of the rational numbers are not equal. So we have to take the LCM to make them equal. So LCM of 12 and 8 is equal to 24. Now the denominators are equal. Now we have to add the numerators only. So we got the number as 19 by 24. So simplify 7 by minus 26 plus 16 by 39. So here, since the denominator is negative, so we need to multiply it by minus 1 with both numerator and denominator. Now for the second case, we will not multiply anything since the denominator is already positive. Now since the denominator of these rational numbers are not equal, so we need to take the LCM to make them equal. We got 78. Now the denominators are equal. Now we just need to add the numerators. So the final answer we got is 11 by 78. Let's move to the module number 12. Find this. So let's take step by step. So here all the denominators of the rational numbers are not equal. So we have to take the LCM of it to make them equal. So we got the LCM as 12. So now we need to multiply 3 in the numerator and denominator. Then the denominator will become 12. In this way we have to multiply the corresponding number to make the denominator as 12 in all the rational numbers. And we have to multiply the same number in the numerator. Now we'll first add the negative numbers and the positive numbers then. So we got the final answer is minus 13 by 12. So evaluate this expression. So here denominators of the rational numbers are not equal. So again we have to take the LCM to make them equal. Let's see step by step. So we got LCM as 140. Now we need to multiply a number with 5 so that we will get 140, and we have to multiply the same number with this both with this rational number in both numerator and denominator. So we got 28. So I'm showing you step by step. Hope each step is clear to you. Now we are simply multiplying the numerator, and now all the denominators are having same value. Now we need to add the negative numbers and all the positive numbers. So we got the final answer as minus 349 by 140. Now let's move to module number 13. So here we need to prove that minus 3 by 16 into 8 by 15 is equal to 8 by 15 into minus 3 by 16. So first we have to take the LHS, that is left hand side, and we have to calculate or simplify it. Now we need to multiply the numerators and then the denominators. So after simplification we got minus 1 by 10. Now let's solve the RHS, that is the right hand side. So again we got minus 1 by 10. So both LHS and RHS we got the same value. So we can write that LHS equal to RHS. Hence this is proof. Now let's take another one. Now let us group the term with the same denominator. First we need to group the terms with which having the same denominator. And we have to write the sign properly. Now since there are equal denominator, so now we can just add the numerator. So final answer we got is 1 by 15. Lecture 4. Module. Let's move to the module number 14. Solve this. Let us take step by step how to solve this problem. So always try to make it simplified. If you can cut any number, first do that so that the number becomes smaller. Don't forget the sign. Please make sure always with the sign. Now we have to do the LCM of 5, 1 and 8, which becomes 40. So we got the final answer as minus 303 by 40. Let's solve this one. I'm showing you step by step. Now we have to make the denominators equal by taking the LCM. So we got the LCM as 24. So now let's make the denominator as 24. And we have to multiply the same number. So first we will add the positive numbers. So we got the answer as 17 by 24. module number 15. Now you have to fill in the blanks. So 27 by 16 divided by which number gives you minus 15 by 8. So now in that blank we can assume the number is in the form of a by b. To convert division to multiplication, we need to do the reciprocal of a by b, that is b by a. So if we transpose this, b by a is equal to minus 15 by 8 into 16 by 727, because 27 by 16, when it goes to the other side, it will get reciprocal. Now simplify it. So we got the value of b by a as minus 10 by 9, but we need to keep it in mind that we need to find the value of a by b. So we know that a by b is reciprocal of b by a. So we need to find the reciprocal of minus 10 by 9, that is equal to minus 9 by 10. So hence the missing number is minus 9 by 10. What number should be added to minus 7 by 8 to get 4 by 9? So let's take the another number to be added is to be x. So now let us take step by step. So if we transpose, so careful about the sign, since minus 7 by 8, it was in the left hand side, it was plus. So now when it transposes to right hand side, it will be minus. So be careful about this. So hence the required number is 95 by 72. What number should be subtracted from minus 5 by 7 to get minus 1? So let's look at the solution. So since it is mentioned the subtraction from minus 5 by 7, so we'll write minus 5 by 7 minus, then the number that should be subtracted, we can consider it as x is equal to get means that is equal to minus 1. Since x is subtracted from minus 5 by 7. Now we have to find the value of x over here. So if we transpose, so this will be minus of minus 5 by 7. So we got the value minus x equal to minus 2 by 7. So x equal to 2 by 7. So hence the required number is 2 by 7. The sum of two rational numbers is minus 5. If one of them is minus 13 by 6, find the other. So one number is given. So let us take the other number as x. Now let us solve this. Again transpose. This minus 13 by 6. Be careful about the sign. Because whenever we are transposing, the sign will be changed. So we got the value of x as minus the 17 by 6. Hence the required number will be minus 17 by 6. Now let's move to module number 16. Exercise. Tell which property allows you to compute this. Now we need to check first whether it is in the form of a into b within bracket b into c is equal to within bracket a into b into c. So yes, this is in this form. So what this property called? Associative property. Now let's represent 7 by 4 on the number line. So first we need to draw a number line. Now give the denominator 4 to each number. So we know that 4 by 4 is equal to 1 and 8 by 4 is equal to 2. So 7 by 4 we can represent it with the point A. So this is the number line representation. Now represent minus 2 by 11, minus 5 by 11, minus 9 by 11 on the number line. So first we need to draw a number line. Make equal division. So here we have, since all the numbers are negative, so we have to take equal 11 divisions. And now give the denominator 11 to each number. Since minus 11 by 11 is minus 1, so we can write as minus 1. Now point the numbers. Minus 2 by 11 as A, minus 5 by 11 as B, minus 9 by 11 as C. Now number line representation of minus 5 by 6. So now give denominator 6 to each number. So minus 6 by 6 is equal to minus 1. So we can replace that with minus 1. So we got minus 5 by 6 and that is at point B. Now module number 17. Example 1. Which of the numbers 3 by minus 4 and minus 5 by 6 is greater? Now let us take the solution step by step. So first we write each of the given numbers with positive denominator. So multiply, in this case the denominator is negative. So we have to multiply it by fraction. Multiply the fraction by minus 1. So we have to do the same minus 1 multiplication in both numerator and denominator. So other number, the denominator is already in positive form. So we don't need to convert anything. Now we need to compare the numbers. First we make the equal denominator. So we have to take the LCM. So the LCM of 4 and 6 is 12. Now what should be multiplied to 4 to get 12? So it will be 3. Let's take a look at the step by step. So we have to multiply 2 over here in both numerator and denominator. Now they have the same denominator. Now we just need to compare the numerator. So now which is a greater number between minus 9 and minus 10? So minus 9 is greater than minus 10. Be careful about the sign. Whenever we have negative sign, then the value which is smaller will have a bigger, will be the greater one, right? So here in this case, minus 9 will be greater than minus 10. So hence, 3 by minus 4 is greater than minus 5 by 6. Arrange the numbers minus 3 by 5, 7 by 10 and minus 5 by 8 in ascending order. So let us take a look at the step by step. First, we write each of the given numbers with positive denominator. So to multiply with minus 1. Now we need to arrange the numbers. First, we need to make the equal denominator and then take the LCM. So LCM of 5, 8 and 10. We are doing the LCM now. So we got 40 as the LCM. So what should be multiplied to 5 to get 40? That is 8. What should be multiplied to 10 to get 40? That is 4. Now what should be multiplied to 8 to get 40? That would be 5. Now let's compare the three numerators. Which is the smaller number between minus 28, minus 25 and minus 24? So now we have arranged the numbers in the ascending order. So in this case, minus 28 is smaller than minus 25 and minus 25 is smaller than minus 24. So hence, this is the, since we need to actually arrange the numbers that is given in the question, so we have to write the corresponding rational numbers given in the questions. Module 18. Which of the following is greater? 4 by minus 5 and minus 7 by 10. First, we need to write each of the given numbers with positive denominator. Now to compare the number, first we need to make the equal denominator by making the LCM of it. So 5 and 10 LCM is 10. So we have to multiply 2. In this case, multiply with 1. Now we need to compare minus 8 and minus 7. So now which one is smaller? So minus 8 is smaller than minus 7. So in this case, since the question is which one is greater, so minus 7 by 10 is greater. Arrange the following rational numbers in descending order. Descending means higher to lower. So let's take the problem with step by step. First, we need to write each of the numbers with positive denominator. To arrange the number, first we need to make the equal denominator by taking the LCM of it. So now we are getting the equivalent rational number. So now compare the numerators and arrange it in descending order. Now rewrite the rational numbers given as per the question. Thank you. I hope you have understood the detailed explanation of each problem. Please subscribe to my channel to get more videos on different topics for different subjects, and you will get in other grades also.